This hearing will come to order. Good morning to everyone here in the room, and particularly our witnesses today. Our hearing today is entitled Transfer of National Nanotechnology Initiative Research Outcomes for Commercial and Public Benefit. I'd like to welcome everyone today on a hearing designed to assess how to ensure that research outcomes from the National Nanotechnology Initiative are transitioned for commercial and public benefit, and I'd like to thank all of our witnesses for being here. The hearing is the third in a series to review various aspects of the National Nanotechnology Initiative, or as we call it, the NNI. These hearings will help guide our development of legislation to reauthorize the NNI during the current session of the Congress. In a past hearing, we received testimony on the importance of developing a prioritized research plan and implementation strategy to address the environment, health, and safety implications of nanotechnology. In another hearing, we heard about the need to educate students at all levels of education about nanotechnology in order to ensure a workforce for this rapidly growing field. Today, the subcommittee will review how well the NNI is supporting activities to make sure the results of nanotechnology research are translated into commercial products and processes. We'll also look at whether the research being supported by NNI in such areas as nanomanufacturing is relevant to the needs of industry. It is clear to me and this committee that nanotechnology can offer this nation and the world unimaginable benefits in a wide range of fields, including healthcare, energy efficiency, electronics, and water remediation. Like many areas, the federal investment in basic research is critical to nanotechnology's development, but this investment will be squandered if we do not cultivate the technology to usable products or processes. The NNI now supports user facilities and basic research in nanomanufacturing. Also, the agencies participating in the NNI administer SBIR programs that fund projects to advance emerging concepts toward commercialization. Certainly, the commercialization of nanotechnology, like any developing technology, is complex. However, nanotechnology has some unique challenges. The development of nanomaterials and devices most often requires highly specialized and expensive instruments. In addition, the scale-up of nanotech requires unique processes that have very low error rates. Furthermore, quality control in nanomanufacturing requires lengthy evaluations and expensive equipment. As I mentioned earlier this morning, I hope to assess whether the current investments aimed at technology transfer and commercialization under the NNI are adequate and reflect the most critical priorities. I also want to look at whether the research is relevant to the industry, and in addition, I'm interested in the views of our witnesses on whether the equipment and instruments available at NNI-supported facilities are adequate and accessible. Finally, I invite any recommendations our witnesses may have on how the NNI could be more effective in helping to bridge the gap between concept and commercialization. I thank our distinguished witnesses for being here today. I look forward to your testimony. And before introducing the panel, I would now recognize my good friend, the ranking member of the subcommittee, Dr. Ehlers, for an opening statement.
Thank you, Mr. Chairman. And in appreciation of the fact we're having a nanotechnology hearing, I decided to offer a nano opening statement so that we can quickly get into the meat of the subject.
I'll now introduce the witnesses.
Reauthorization of the NNI is a prime opportunity for the Science and Technology Committee to continue to craft policies that encourage U.S. innovation and maintain our global competitiveness. We have invested more than $8 billion federal dollars into the NNI since it was initiated in 2003. The reauthorization measure will be a very important piece of legislation and deserves the full attention of this subcommittee and the full Science Committee. There is still much to learn about perfecting nanotechnology manufacturing processes. To those working in nanotechnology, it is evident that there are many challenges unique to the nanomanufacturing supply chain. The conventional balance of basic and applied research and development may not be a good fit for nanomanufacturing because of the high capital investments and substantial fundamental research necessary to overcome obstacles to commercialization. As we advance the reauthorization of the National Nanotechnology Initiative, this question of appropriate balance must be carefully considered. I look forward to hearing from our witnesses about their recommendations for investment priorities in the reauthorization process. That's Mr. Chairman. I yield back.
I thank the ranking member. And if there are other members who arrive, as they tend to do during the course of the hearing, who wish to submit additional opening and statements, their records will be added. At this point, it's a privilege to introduce the witnesses. Mr. Skip Rung is the President and Executive Director of the Oregon Nanoscience and Microtechnologies Institute, who flew a red-eye flight here. Mr. Rung, welcome. I am sometimes referred to as the representative from the 3rd District of Washington or the 6th District of Oregon, owing to how many people cross the river each day to work. We welcome you particularly here as well. Dr. Julie Chen is a Professor of Engineering at University of Massachusetts, Lowell, and Co-Director of their Nanomanufacturing Center of Excellence. Dr. Chen, welcome. Dr. Jeffrey Welser is on assignment from the IBM Corporation to serve as the Director of Nanoelectronics Research Initiative, NRI, a subsidiary of the Semiconductor Research Corporation. Welcome, Dr. Welser. Dr. William Moffitt is the Chief Executive Officer of Nanosphere Incorporated and is also representing the NanoBusiness Alliance. Dr. Moffitt, welcome. And Dr. Mark Melliar-Smith is the Chief Executive Officer of Molecular Imprints Incorporated. So we have folks from both the academic research sector and the applied industry business sector. As our witnesses should know, spoken testimony is limited to 5 minutes each, after which members of the committee will have 5 minutes each to ask questions. And as I mentioned earlier, this is a friendly, bipartisan committee, and we really welcome your discussion. We will offer an exchange of questions. Always feel if there's something critical we have yet to ask, that you can offer insights into that as well. We will begin our questioning or comments from Mr. Rung. Thank you for being here.
Chairman Baird and members of the committee, I'm honored by the opportunity to speak with you today on a subject of great importance for the continued economic and social health of our nation. Winning at science-based innovation is critical for U.S. economic competitiveness, for the supply of jobs with productivity sufficient for the wage levels Americans have come to expect, and for the prosperity that pays for all the social goods, such as health and education, we would like to leave intact for future generations. Reauthorization of the Nanotechnology Research and Development Act presents the opportunity both to re-up on a vital investment and at the same time be more intentional about reaping social and economic returns. Oregon Nanoscience and Microtechnologies Institute, Oregon's first signature research center, has so far received $37 million from the Oregon Innovation Council because they know that success in the global competition for jobs and prosperity completely depends on a traded sector that wins through innovation, fueled by research and entrepreneurship. And so that is the dual mission of ONAMI, growth in scientific research and growth at Oregon employers commercializing that research. I think we're an interesting case. We are a small state, but arguably we have the world's most powerful collection of industrial nanotech R&D assets, Intel and HP's top research sites, FEI Company, and Invitrogen molecular probes, among others. But we have no wealthy private university, and we are not a traditional venture capital hotspot. Still, we know for certain that our research is competitive, and we therefore should be able to grow our entrepreneurial sector. So therefore, one of ONAMI's core activities is a commercialization fund that makes grants to bridge the very real gap between what research agencies pay for and what pencils out for investors. We have so far enabled 3 very promising microtechnology companies and 4 nanotechnology spin-out companies. Time permitting, at the end of my remarks, and it probably won't, I'll say a little bit about our nano group. For now, I will simply note that the support we provide is absolutely critical for these technologies to ever reach customers and create jobs. Before addressing directly the questions asked by the committee, I will state my overarching point. Intentional federal investment in and accountability measures for entrepreneurial startup company-driven commercialization of NNI research are just as necessary and important as the research itself, and therefore should be a prominent consideration in the reauthorization. It's interesting that today, in contrast to 30 years ago, most high-risk and disruptive innovation takes place in small companies, many of them venture-backed startups. Venture money originating in pension funds and endowments turns out to be more patient and risk-tolerant than corporate cash, and large companies increasingly innovate by acquisition and open technology sourcing from small companies. This is why there needs to be intense focus on making U.S. nanotechnology entrepreneurs successful, understanding and addressing the myriad hurdles that they face. So then, what are those hurdles? They are the greater expense and time required for proof of concept demonstration, comparatively high capital requirements, the need for convenient access to specialized facilities and expertise, and often very complicated technology licensing situations. And this is not to mention the growing burden of regulatory compliance and related uncertainty. Investors see these things as risks and they act accordingly. For all these reasons, the appetite of venture capital for nanotechnology has turned out to be less than many hoped and expected. This may not necessarily be the case overseas, as hungry global competitors such as China place a higher value on economic development. To address these hurdles, the Bayh-Dole Act has enabled universities to own and out-license federal research results, and in the process provide an incentive to faculty and vendors. The NNI has established 13 user facilities at universities, though with no recent additions, and the national labs have various access mechanisms. SBIR and STTR are vital programs and a lifeline for many innovative small businesses, including our own lead nanotechnology spin-out Crystal Clear Technologies. The new TIP program looks very promising for companies past the seed stage. All these things are very good and should, if anything, be expanded, but they don't take as much advantage as they could of America's many local business and investor communities, so company and job creation still favor the already successful technology communities around the major centers. I'd like to suggest to you two concepts based on our experience with shared user facilities and our GAP fund that I believe could increase the commercialization return on the NNI investment. The first is to broaden the NNIN concept into what we call the high-tech extension service, the logical modern analog of the invaluable land-grant concept of 150 years ago. We started too late to be part of the NNIN, but bootstrapped federal and private equipment grants with university and state funds to create a network of shared user facilities which consolidate major instrument and equipment assets in well-utilized and maintained facilities open to all academic users from any campus on equal terms. They are also open for industry collaborations, and we can provide leased experimental and office space to both large and small company partners. All 7 of our current GAP fund companies make critical use of these facilities. Since Oregon is a rural state and the distance between our sites is up to 110 miles, we have also implemented high-quality webcam and virtual network connections on major tools to enable a very satisfying remote user experience. This also works well cross-country, so we have clients as far away as Florida. But the key points here are that there are measurable objectives and business models tied to facility utilization by industry, that we share and coordinate acquisitions statewide to maximize unique capability, and that this approach does not need to be limited to the few NNIN sites, which are too far away for our companies to use on a regular basis. Our concept could conceivably go viral, so to speak, if other state and federal funding policies encouraged it. We're very proud to have opened our newest facility at the University of Oregon on February 19th. It's a 30,000 square foot underground lab with about the best vibration performance anywhere in the world, and therefore the greatest location possible for the latest in nanotech tools. We are installing, for example, the first of 2 FEI Titan transmission electron microscopes. We'd love for our nanoscience user facilities to be part of the national network and database of nanoscience assets with or without NNIN funding. The second concept is dedicated funding for commercialization tied to research centers. As far as we know, we are the only state-funded research center to have its own dedicated GAP fund. This has been running for about 15 months, and if we are sure of anything at this point, it is that the response to this incentive from academics and entrepreneurs has exceeded our expectations and changed the culture and conversation around commercialization. This fund is actively advised by the leading venture capital partners investing in Oregon, including both large and small funds. The advisors get a heads-up look at potential deal flow, and our inventors and entrepreneurs get early time with the best possible investor audience. We ask the advisors one question: if we fund this project and it meets its technical objectives, can the partner company raise capital within 12 to 18 months and go on to build a successful business in Oregon? We get more insightful answers to this question than we could come up with ourselves and have always followed the advice. The GAP Fund has one success metric that the state measures us on: private capital dollars invested in our GAP Fund companies. This is a very unforgiving metric and one that is impossible to fudge. Our 4 nano companies are very early stage and have...
Mr. Rung, I'm going to ask you to summarize here at this point.
Okay, so the GAP Fund we think is a great process to institutionalize with grants tied to the National Nanotechnology Initiative, and thank you very much.
Thank you very much. We'll likely follow up with some questions about that. Excellent testimony. Dr. Chen.
Thank you, Chairman Baird, and the other committee members for inviting me here today. I'm Julie Chen. I'm a professor of mechanical engineering at the University of Massachusetts Lowell, and I'm also co-director of a state-funded nanomanufacturing center of excellence. I would be remiss not to pass along the best wishes and greetings of our university's new chancellor and your former colleague, Marty Meehan. UMass Lowell is also part of a very unique equal partnership with Northeastern University and the University of New Hampshire in a National Science Foundation-funded Center for High-Rate Nanomanufacturing. This is one of only 4 such centers in the United States focused on developing tools and processes for high-volume, high-rate production. The center has partnerships with over 24 companies, and these companies represent the full spectrum of industry sectors and company size, everything from startup to Fortune 100. Mr. Chairman, we've seen that from drug therapies, efficient energy sources, protection for our warfighters, innovative nanotechnology is going to be important for this nation. We're not the only country to recognize the possibilities of nano. Several nations in Europe and Asia have made nano a national priority and have invested heavily in its expansion. As with much of the U.S., the city of Lowell has seen its share of industry strength and loss, and from the textile industry to mini computers to biotechnology. As a nation, we cannot afford to have a laissez-faire approach to technology transfer of the research coming out of nanotechnology. Today, I'd like to concentrate my specific comments on four points. The first one is company attitudes. I'm aware of 2 major surveys that have been done of business leaders and their attitude towards the nanomanufacturing industry. Most recent, one conducted in 2006 by a team led by Barry Hawk, was a collaboration between the UMass Lowell Center for Economic and Civic Opinion and Small Times Magazine. A prior survey funded by NSF was conducted in 2005. The results are consistent. Of the respondents, almost 90% felt that the federal government should participate or take the lead in fostering R&D and providing commercialization incentives. In both surveys, items like the high cost of processing, perception of lengthy times to market, and process scalability were cited as key barriers. It's clear that industry believes that federal government funding is really a key to closing the gap between the early successes that we've had in the lab and delivery of products. An additional note is that 89% of these business leaders also stated the importance of EHS risks, which the subcommittee has addressed. At Lowell, we have EHS researchers working side by side with nanomanufacturing researchers, measuring potential levels of exposure and making suggestions in terms of the chemicals and materials that could be used to ensure that the products that we develop in the future and the processes are greener in their development. It's this type of multidisciplinary partnership that we need to foster and to encourage to help move this technology forward. The second point is in terms of basic research. Over the past decade, we have made significant advances in fabrication of the building blocks, the nanotubes, the nanoparticles. And we're getting a better understanding through experimentation and modeling of how forces interact with these building blocks. We've only scratched the surface, though. We haven't yet gotten to the point where we can sit down and design the process and the product for a nanotechnology-related product. So here, what I'd like to do is emphasize that we need to think of nanotechnology not as a single industry sector or a single way of making products. Differences that we see, in fact, today in manufacturing between making steel, making a medical device, making an electronic device, carries over through nanotechnology. And we can see from the 4 NSF centers that is true. Many different mechanisms, fluidics, optics, electronics, are being used, and we need to recognize that there is this broad array of techniques. So I'm going to talk about 3 examples in terms of basic research that cut across these different processes rather than specific ones. The first example A is inline metrology. To paraphrase one of my colleagues, Professor Carol Berry at UMass Lowell, you can make 100 products in an hour, but it's going to take you a week to figure out if any of them are any good. We need inline rapid measurement in order to move process development forward. Example B, processing equipment. It takes more than just making the filament to make the light bulb. You need to make the filament, the bulb, the battery, the switch, and put that all together. We need more efforts in terms of the processing equipment to integrate these things. And the third area is models. We see from nature that things are not perfect. In a spider web, you have radial lines, nice little circular lines, but they're not all perfect. And yet the web still is able to catch the fly. We need to understand from modeling how perfect do we have to be in order to truly make commercial products. My third point is in terms of university-industry interaction. We believe that a percentage of funds needs to go towards technology demonstration projects, in the form perhaps of an STTR program, but allowing both small and large companies to participate, because nanotechnology really is going to be important in both. The other thing that we would say is that the bulk of federal support should not be targeted. We cannot prevent the discovery not yet envisioned from being funded, but the small percentage of funds for these technology demonstration projects will help to focus and drive the research forward, and will help to dispel any concerns from venture capitals about the commercial viability of nanotechnology. My last point is in terms of user facilities. Over 90% of the business leaders stated that unique facilities were critical to their advancement. Of these, smaller companies are more likely to use user facilities because of the lack of resources. But again, user facilities should not just be limited to the traditional characterization and lithography based. We saw there's many different ways of making things, and we want to make many different types of facilities available across the country. So the idea of not just selecting a few, but allowing any facility that shows that there's industry interest to have some funding to provide for that support, administrative support, is important for moving this. So in conclusion, Mr. Chairman, members of the committee, I would like to thank you again for the opportunity to testify. I believe there's an important role that NNI and the federal government can play in fostering this technology transfer. The bulk of funding for R&D must remain at the basic research level to seed the emerging technologies of the future. But a few of these targeted funds in terms of university-industry partnerships for technology demonstration, for developing tools and processes, and for addressing things like EHS and IP are going to be important to move forward this technology. Thank you.
Good morning. My name is Jeff Welser. I'm on assignment from the IBM Corporation to head the Nanoelectronics Research Initiative, or NRI. I appreciate the opportunity to testify today on behalf of the NRI, the IBM Corporation, the Semiconductor Industry Association, and the Semiconductor Research Corporation. Let me start by noting that, as its name implies, NRI is focused on nanoelectronics, which is the application of nanotechnology to the electronics field, including the semiconductor devices and chips which fuel our economy today, from supercomputers to laptops to cell phones to automotive electronics. This industry has been built on constantly shrinking the size of these components, and arguably was the first industry to begin exploiting nano for commercial products. But now we are quickly approaching the fundamental limits of the current technology, and we will need to find entirely new devices to continue these unprecedented technological advances. It's not just about shrinking things anymore. It's about taking advantage of the new physics that comes with small sizes to create new functionality. The same promise nanotechnology holds for so many other fields of science as well. And so many of the advances in these other fields, as well as in the economy as a whole, will depend on semiconductors. Our success will be crucial to America's overall competitiveness. Simply put, whichever country is first to market with the new chip technology will lead in the coming nanoelectronics area the way the U.S. has led for half a century in the microelectronics era. In the next 5 minutes, I would like to focus my remarks on two key questions submitted by the committee. I'll answer these in the context of how our initiative is advancing and commercializing nanoelectronics, but I feel strongly that the partnership model and approach we employ can be utilized across all of the areas of nanotechnology that the NNI addresses. First, given our industry's grand challenge of finding a new semiconductor device, how do we interact with government to set research directions and manage research activities? The NRI's model is to do goal-oriented basic research. This model balances the need for a broad range of research into many different science phenomena with the need to drive the research in the most productive directions for future commercialization. All of the NRI's research is done at multi-university centers, and we are currently supporting work at 25 universities in 13 states. Centering the work at universities rather than in our own industrial labs or at national labs is important, not only for driving the research, but also to expand the number of involved students which will make up a future workforce and leverage related university work. To engage the largest number of top researchers across the U.S., we have set up 3 centers already in the West, the Northwest, and the Northeast and Southwest, and are looking to open a 4th in the Midwest later this year. Building a strong university capability for nanotechnology research in general is crucial to increasing American competitiveness for all industries. Utilizing both the federal NNI funding and state initiatives, we currently partner with government in 3 different ways. First, our centers are strongly supported by funding from the lead state in each case, California, New York, and Texas. These states recognize that close industry, government, university partnership leads to faster commercialization of the research, thereby increasing the potential for future economic development activity. In short, they see the impending technology transition point as an opportunity to grow an entirely new industry around their university base, the same way Silicon Valley grew up around the transistor. Second, NRI and NSF provide supplemental co-funding of nanoelectronics projects at existing NSF, nanoscience, and engineering university centers. Our industry liaison team then interacts with the centers and gives industry input on the individual projects, as well as the overall center research. This leverages a significant NSF investment in these centers, guiding that work toward areas we think will have large potential for future commercialization, and giving us a broad view of many emerging areas of research. Third, NRI and NIST started a new partnership last September to extend the NRI center work. NRI and NIST now jointly choose projects to fund, conduct joint reviews, and hold monthly meetings to direct the ongoing program. In addition, the NIST labs and researchers can interact directly with university professors to support the nanoelectronics work, leveraging the lab's capabilities for advanced nanometrology and helping to guide their continued work internally on new revolutionary tools that can have the most impact on future commercialized products. This partnership model is unique and utilizes the best of university, industry, and government partners to produce results most likely to benefit future products. This leads naturally into the committee's second question: how can NNI help foster commercialization of nanotechnology? First, increase funding across the agencies for nanotechnology equipment and research at universities. This is similar to what NSF has been doing with the National Nanotechnology Infrastructure Network, but expanding the equipment base to enable nanomanufacturing and prototyping of early devices will facilitate a more rapid transition from the lab into a commercial product. Second, encourage direct partnerships with industry to pursue this research. Industry involvement leads naturally to identifying early commercialization opportunities for nanotechnology, such as the recent introduction of nano self-assembly to fabricate air gap wiring in IBM's computer chips based on work being done at the Albany Nanotech Center. And industry involvement can even help direct basic research in the most promising directions. As an example, at a 2006 NRI review, a physics professor presented work on a new phenomenon he dubbed pseudospintronics, which occurred far below room temperature. After discussions with industry research engineers about the potential for utilizing this phenomenon in a future device, by the next review, he was showing us how the phenomenon could be made more robust for higher temperature operation, and even had a novel idea of his own for a new transistor based on this effect. This is the university-industry synergy that NNI should strive to achieve in all areas of nanotechnology research. In my written testimony, I've given 5 specific recommendations to the committee, but the 2 key points I hope to leave you with today are: 1, we would like to see the NNI reauthorization include increased federal funding for both equipment and research at universities, and strongly encourage government, university, and industry partnerships to guide this research into commercial applications rapidly. And 2, we would like to see the NNI reauthorization include a strong focus on nanoelectronics in particular, including it as a priority program activity across the agencies. In closing, I'd like to point out that the magnitude of the effort we face finding a new transistor is equivalent to what was done in the 40s and 50s as we developed the first semiconductor device that replaced the vacuum tube. Research on this scale, both in terms of time and money, is more than individual companies can possibly fund. It is also more than universities alone can conduct with current limited federal funding. Thus, close collaboration among industry, academia, and government is absolutely necessary in order to solve this grand challenge and ensure that the U.S. remains the leaders in the nanoelectronics era. Thank you, and I look forward to answering any questions you may have.
Thank you, Mr. Chairman, Ranking Member Ehlers, and members of the House Research and Education Subcommittee of the Committee on Science and Technology for the opportunity to testify on this important issue. I'm Bill Moffitt, Chief Executive Officer of Nanosphere Incorporated. Nanosphere develops, manufactures, and markets an advanced molecular diagnostics platform, the Verigene system, that enables simple, low-cost, and highly sensitive genomic and protein testing on a single platform. Our mission is to improve the diagnosis and treatment of disease by enabling earlier access to and detection of new and existing biomarkers of disease. Nanosphere was founded in 2000 based upon nanotechnology discoveries made by Dr. Robert Letzinger and Dr. Chad Merkin at Northwestern University in Evanston, Illinois. We have taken basic science funded by NIH and NSF and out of the university research setting and translated it into a diagnostics platform that delivers three distinct value propositions across a variety of fields. The ability to economically move complex genetic testing into mainstream medicine. Second, earlier detection of diseases such as cardiovascular disease, cancer, and neurodegenerative diseases as nanoparticle probes improve detection sensitivity by orders of magnitude. And third, the potential to test for diseases where no tests exist today, as low abundance biomarkers of active disease are undetectable by current technologies. Moreover, while we are focused on medical diagnostics, this same technology platform is applicable to biosecurity, agricultural and food safety testing, and industrial contamination control. Nanotechnology has the potential to shift markets and a global economy and replace or greatly modify existing leadership positions. As such, it represents both a challenge and an opportunity for American competitiveness. With that as the context for my remarks, I'd like to share with you my thoughts on the 4 questions upon which the committee has sought input. First, the hurdles to commercialization of nanotechnology. First and foremost is the lack of early-stage capital for cutting-edge translational research. Much of the government's direct spending in nanotechnology has been on scientific discovery. It takes extensive capital to translate nanoscience discoveries into platform technologies and demonstrate potential and commercial viability in order to attract the capital required for commercialization. For example, at Nanosphere, up to the point of first commercial product launch, we invested over $100 million in converting nanoscience to scalable product technology platform. Many great nanoscientific discoveries failed to attract the extensive capital required for commercialization, and for this reason, the gap between the research lab and the product prototype is often referred to as the Valley of Death. There's a great need to balance spending on basic research and translational work or goal-oriented development programs, and to focus such programs on specific areas with the greatest promise of benefit to the national interest. Another hurdle to commercialization of nanotechnology is the difficulty in finding technical talent. Nanotechnology has need for highly trained scientists from multiple disciplines. These highly paid, high-quality jobs are difficult to fill because of the well-documented decline in STEM graduates. In addition to PhDs, nanotech companies also need trained and skilled laboratory and manufacturing technicians. There are currently very few technical training programs that fill this need. We can address both issues by developing vocational curricula and deploying them in community colleges and encouraging internships by high school and college students that expose them to nanotech as a career. The second question was federal programs that can help bridge the Valley of Death and how effective SBIR, STTR, and ATP programs have been. Conceptually, these programs have helped in this process, but often these grants fail to provide a sufficiently significant amount of capital. Of the $100 million in high-risk capital spent by Nanosphere in its march to first commercial launch of products, approximately $7 million was provided by government funding sources. However, if I subtract the biosecurity contract, the total government support has been less than $2 million. To some degree, the competitive process of grant review and award provides third-party verification of the potential value of the science, especially in early development phases where capital is at high risk. What the government can do to address this need for focused high-risk capital is to provide additional incentive for private sector investment in the form of a program of tax and investment credits which will help mitigate risk for early capital and provide additional incentive for investments directed at goal-oriented research and development programs. Focusing investment and tax credit programs at specific problems enables the government to broadly direct investment while placing the onus of efficiency and effectiveness of investment on the private sector. Since private investors use a competitive, market-driven mechanism to select companies, these tax and investment credits will benefit those companies with the most potential to produce meaningful applications. The third question was whether or not there are areas of focus for commercialization that will position the nation for leadership. These goal-oriented development programs will translate much of this new science into platform technologies that will likely impact several industries. But clearly there are two areas of focus where the U.S. has strong potential: energy and healthcare. Our growing energy needs are evident, and in healthcare we are both the largest provider and largest consumer in the world. Historically, healthcare has not scaled the way other industries have, driven by innovations in technology. Where is the leverage? Nanotechnology holds promise for impacting every aspect of medical care, from research to diagnostics to imaging to therapeutics. Nanosphere's molecular diagnostics platform is but one example of nanotechnology enabling breakthroughs in medical diagnostics, replacing technologies that are decades old. In conclusion, the U.S. must retain its leadership position in this industry-changing technology, which has the potential to realign global competitiveness. The U.S. government must set the gold standard in supporting an efficient and productive climate, not only for discovery, but also for commercializing nanotechnology innovation. Not only will such an initiative enhance American competitiveness, but it will also address significant issues that will impact generations to come. Thank you, Mr. Chairman and members of the committee.
Good morning. My name is Mark Melliar-Smith, and I'm the Chief Executive Officer of Melliar-Smith. My company is but one example of the successful support of new technology by the U.S. government. Molecular Imprints is a startup company which was spun out of the University of Texas, Austin in 2001. The company was created to commercialize a newly invented technology called step-and-flash imprint lithography, which demonstrated the capability of about the diameter of a nanolithography is the method of creating very small patterns on a substrate. The technology is critically important, especially in the production of electronic devices.
Could you make sure your mic's on, Dr. Smith?
Is that better? It's begun to be limited by the wavelength of light. It's very difficult to make a 50 nanometer feature with a 20 nanometer light source. Molecular Imprints has developed a superior alternative technique called nanoprinting. We make a very accurate master using an electron beam tool of almost unlimited resolution, and then use the master to simply print using a special ink the features on the substrate. As you can see from this graph, the quality of the images are much better, and the simplicity of the tool makes it much less expensive. The analogy to photography can be extended here. We don't make prints photographically anymore, we simply print them. The step-and-flash imprint development will have significant impact on the United States economy. The original optical photographic techniques were invented in the United States in the late 50s and early 60s and built up into a billion-dollar industry. However, in the 80s and 90s, the U.S. lost this capabilities to superior products from Europe and Japan, and now this $10 billion industry is almost entirely sourced from outside the United States, as shown in this chart. At Molecular Imprints, we intend to turn this around and bring the business back to the U.S. through the use of new and superior nanoprinting technology. However, the economic impact extends well beyond the $10 billion annual market for the litho tools themselves. This technology enables multiple industries. The largest is the $250 billion computer chip industry with companies such as Intel and Texas Instruments, which itself enables the $1.5 trillion electronics industry and much of our advanced weapon systems. This industry has been built over the past 50 years on our ability to make smaller transistors every year. The disk drive industry, with companies such as Seagate and Western Digital, is also moving into nanotechnology. To increase the density of their drives, they will soon have to start patterning the magnetic disks themselves. And I've shown an example of this in this particular chart here. What you can see are 20 nanometer magnetic pillars on a magnetic disk drive, and a large disk drive in the future will have 10 trillion, yes, that's trillion with a T, on each drive. We're also working with the LED industry to place nano features on high brightness light emitting diodes to increase their efficiency and brightness. The objective is to make the LED a replacement for all forms of architectural lighting, which, if completed, would save a significant fraction of all of the electricity used in the United States and remove about 50 million tons of carbon from the air each year. Finally, looking further out, there's growing interest in the use of nanomedicines. By making the drugs into small particles, typically less than 50 nanometers and of a particular shape, there's evidence they can be made much more effective and much more specific. To create this opportunity, we received a large amount of help from many different government agencies, shown in this slide here. And the purpose of my testimony today is to mention that. As you can see, and I won't read through them, we've received support in significant amounts from several different government agencies and also from the University of Texas. In all the cases, the programs and project management of these funding agencies has, in my mind, been impeccable, maintaining fiscal responsibility for the taxpayer without overly micromanaging the technical efforts. We've also received extensive help from government-funded facilities. Recently, especially useful has been our access to state-of-the-art electron beam tools at the Molecular Foundry at Lawrence Berkeley National Laboratories in California to make the very fine imprint marks required for our technology. The government funding has been supplemented by over $60 million of venture capital and industry investment. And in fact, in my experience, I found no dichotomy between the two sources of funding. They seem to be synergistic and collaborative. We're grateful for all of this support. Our company has already grown to 90 people, and I might add, with an average salary of $95,000 a year, so they're really good jobs. And we expect to get $25 million in revenue this year, twice that of 2007. And essentially, we see almost unlimited future for ourselves and our customers. None of this would have been possible without the various forms of support I have described. Now, I think we all know that one swallow does not a summer make. But if you'll grant me an example of one, I would say the programs have been very successful. Thank you.
Outstanding testimony, and we appreciate very much your insights and expertise. I want to focus on two things. One of the, as we look to reauthorize the bill, give us, if you could, and I'm going to rule out one option. You can't just say more money. We hear that enough on Capitol Hill. We have a $400 billion deficit this year, a multi-trillion-dollar debt, as you know, and so the more money thing I will take off the table. Apart from that, what, if you could each pick one thing to do and one thing not to do as we look towards reauthorizing this bill, what would that be? And I'll go, Mr. Rung, work across from you.
The one thing to do would be to have some intentional and accountable with measures funding for commercialization associated with multi-year large awards. So that might take the form of a gap fund such as ours that provides an incentive and some specific funding. In our cases, it's grants to university projects in collaboration with entrepreneurial startups, with the goal being that the startups raise funds. In terms of the one thing not to do, I wasn't prepared for that question, so I guess I'll kind of punt and say more of the same without thinking through.
If it comes to you later on, the reason is that we've yet to repeal the law of unintended consequences. That's the one law that doesn't sunset here, so I'm always cognizant of, I ask this very often, whatever the topic, because I just want to not make mistakes that set you back in our effort to move things forward. Dr. Chen.
The one thing to do, I think, would mirror what Mr. Rung said, which is to take a portion of it and have it targeted to help and support university industry partnerships on a few specific areas and projects. In terms of things not to do, I think the flip side is for the basic research funding, you don't want to target that too much. You want to leave that open, because that's where you don't want to pick and choose what the winners are, because then you prevent the unexpected discovery from happening.
Since they already took my university industry partnerships, the other thing I would say is do look to what the states are doing as well in this. I mean, the states are being very responsive to the NRI in particular in terms of finding that as an opportunity to build up new economies. And they're willing to invest money in buildings and facilities around the universities. They can't necessarily afford all the equipment and things that are going to go into that, or the types of infrastructure costs that go along with it. But they're ready to catch a lot of this stuff as it comes out, and will be more than willing to fund startups as well on that. So I think leveraging that capability with federal funds is very important.
I'd like to see the initiative balance spending between basic research and bridging the gap to commercialization of products. Historically, we focused a tremendous amount of money and effort at developing the science. It's now time to bring some of that through to fruition so that those industries' profits and jobs can begin to fuel and repay back into the cycle, if you will. The thing I wouldn't do is ignore the need for funding to develop human resources. To all of us that are in the commercial side of this is extremely critical.
I think the point that I would like to focus on are the utilization of the national laboratories. They've been built up over 50 years or longer in the country, and they're an enormous resource for the economy and the well-being of the nation. I think anything that we can use to try to draw the national labs more into the world of innovation and commercialization would be enormously beneficial. After the Second World War, this nation and a lot of its industries were built on the basis of large corporate laboratories, which now unfortunately have fallen generally on rather harder times. So it's rare that you can find a really talented group of multidisciplinary world-class scientists, and those are located in the national labs now. But somehow we need to find a way to get them more involved in I think, that sort of activity. In terms of the one thing that don't want to do, it's always difficult for me to say stop doing something because I've only been mostly dealt with successful activities with the government. So if I might be excused from straying a little bit out of perhaps this committee, I would like to see us not deny immigrants the chance to work in this country. They have, many of the universities have got large numbers of graduate students who are not born in the United States. They're another enormous beneficial aspect of our university system which we ought to be able to exploit. Thank you.
Outstanding comments. I want to go, my time will shortly expire, so I want to, on the second round, I'll be asking you about education issues, and particularly issue of, given the large infrastructure, or expensive infrastructure, maybe better said, that it costs to do nanotech work. How do we export that? Can we use web-based instruction or remote access to help, for example, community college students, et cetera, along the line of something Mr. Moffitt said, but I hear it from nanotech folks as well, that the pipeline of students, so we get this great gee whiz development, great economic potential, but we don't have the pipeline, and that's one of our risks in terms of where we lose the technology, is another country has the human resources to exploit the developments that we make here. We've seen this in other fields in the past. So I'll yield to Dr. Ehlers, or recognize Dr. Ehlers for 5 minutes, but I'll get back to that question in a moment.
Thank you, Mr. Chairman. And first, I'd just like to make an observation. Looking around the room, you'll notice that this hearing is fairly lightly attended, both in the audience and by members. And I don't even know if members of the press are here. But yet, I think this particular hearing, and certainly this topic, will have much greater impact on the future of this nation and its economy than most anything, certainly more so than whether or not Roger Clemens took steroids, which has preoccupied the press and part of the Congress for some time.
If we had the proper chips, we could have assessed whether he took steroids. A plug for Mr. Moffitt's enterprise.
Yes, right. And it's striking to me, and it shows me the importance of this committee and the lack of understanding of the public and occasionally our colleagues of the importance of the issues that we deal with. I thank the panel for being here. Your testimony's been outstanding and very helpful to me. In some cases, you've answered the questions I was going to ask, but let me just try to get a cross-section. A few of you have answered this already, but I want a broader and more complete response. For example, Mr. Moffitt and I think Dr. Chen as well, mentioned that the U.S. currently leads in the science of nanotechnology, but could lose the commercialization race. Now the question is, how can we turn that around? It's not just a matter of money, you know as well as I. Education comes in here, a lot of other factors. You also mentioned immigration. I think I would refer you to John McCain's campaign. Maybe you can help in that process, because he seems to be the only one supporting proper immigration. But what's your answer? What can we do in the federal government to help with the commercialization, given our current budget situation? Not a lot of money. What do you need? You need more encouragement. You need more security to be able to raise money, etc. What's your response? Dr. Chen, why don't you kick it off?
I would say that actually one of the things goes back to what you referred to, which is why people aren't interested. And it's the technology demonstration projects, I think, is something that can address both issues. Because if you have a few examples of things where we've taken things from the lab and turned it into a commercial success, it starts to feed the pipeline. People see that you can succeed, that you can accelerate progress in a particular area, and the success there makes people realize that you can have success in other directions. So I think these technology demonstration projects where university and industry work together is one area where you don't need a huge amount of investment, because you're not going to invest in hundreds of them, but if you invest in a few as a starting point, you can make things move forward. And in terms of the education and immigration, I totally agree. I think that this country needs to recognize that we're going to lose a lot of knowledge if we make it difficult for people to stay here. My parents came here as graduate students. I was born here. And so that is an example of how encouraging the people we train to stay here is going to help this country.
Mr. Moffitt?
The single greatest hindrance to commercialization, I think, today, and keeping it in this country, is at the root of that is education. We simply lack the workforce. This requires a highly skilled, very technical labor organization, not dissimilar from what the semiconductor industry required 15, 25 years ago. So this, again, is against a falling tide of graduates, in STEM graduates, if you will. So I think education is certainly one key to the answer here. And I think the second is the ability to provide validation for the private sector investments in a given nanoscience. And one of the greatest difficulties is that extremely high-risk capital that's used to start a small venture, and then have the ability to cover the gap, if you will, and prove out the commercial viability or value of the product. And that, I think, is where if the government would focus spending, I won't say more, but spending on the gap, if you will, that serves to validate, and validation brings in private sector money, of which there is an abundance in this country.
Okay, I appreciate those comments, because I've spent about 40 years of my life trying to improve math science education in the elementary and secondary schools, including during my time in Congress. Just a quick follow-up, Mr. Moffitt, and then there'll be a quick question for Mr. Melliar-Smith. Are you having trouble filling spots in your company? Are you having trouble hiring qualified people?
Most definitely.
Okay.
In fact, I would tell you very quickly that yesterday in a staff meeting, we discussed the potential to move manufacturing of our products offshore to get access to a labor force that would be sufficient to supply our needs.
Okay, and a quick follow-up from Dr. Melliar-Smith. You commented about use of national labs. How about university centers?
Well, I believe the universities also fall into the same category of being a national resource for research and development, and one I might add that's very hard to duplicate or outsource. It takes several generations to build a great research university, and we need to support those activities. The only comment I would make in the form of sort of constructive criticism, if I may, is that I think that the universities could provide an increasing reference towards commercialization in their tenure decisions for professors. We've been very fortunate in having a professor at the university who spent a lot of time at Molecular Imprints as our chief technical officer. I'm not sure that it has helped his tenure track to a full professor position, and I think in some universities such activities are in fact almost frowned upon. So any encouragement we can give to universities that commercialization of the inventions which they act as a wellspring for could be used to further the academic career of the professors.
In my experience in universities, the answer has been that the professors go off and form their own companies and take care of the commercialization that way, which is not healthy for the universities. With that, I yield back.
But it makes tenure a whole lot less relevant if you're successful.
Go back and donate a building.
Dr. Lipinski.
Thank you, Mr. Chairman, and I want to, I'm going to try not to repeat some of the same questions. I think all three of us doctors up here think alike on these questions, but I wanted to echo a little bit what Dr. Ehlers said about the lack of interest apparently here on this issue. Tomorrow we're going to have Bill Gates in this room, and I'm sure that everyone will be packed out the doors. The media will be here, and then Bill Gates is going to come and address he's going to come talk to the Democratic caucus. I really think what we should have, would probably be more important, more helpful to our country, is have the five of you come and speak to the Democratic caucus and see if you could really raise the interest. I think it's I've been discussing this. I don't know if it's because people hear nanotechnology and they just don't understand it. They feel like it's too complicated, but I really think that this is critical to the future economic prosperity of our country. And just a couple of things sort of around the margins from coming off from the questions before. What have some of the states done that you see as very successful in terms of helping to promote nanotechnology? I know that New York has done a lot, but who else has done things that you think are successful? Start with Dr. Welser.
So yeah, obviously New York I think is a great example. So I won't dwell on that one right now. The other things we've seen going on though in Texas, they put together an endowment for pulling in new faculty specifically in the area of nanoelectronics and nanotechnology when they started the center, which then allowed them to pull in sort of a more get more of a critical mass of people there working on this effort for both for training the students and for doing the research. I think that's actually extremely useful because getting enough people at a given university center to work on it oftentimes makes a difference between whether you just got a few good projects coming out from one professor's lab or a whole bunch of ideas building off each other. The other thing we see is in one of the Midwestern states that we're looking at right now, they are specifically looking to try and build up incubators outside of the university that can catch some of the spin-offs, but have the university professors help them in the design of that and actually be able to utilize those facilities in the early stage research before it's ready to be necessarily a technology that's going to go out for actual R&D. I think this is a somewhat smaller investment than what, say, New York did to build the entire nanotech center there, but by doing that in a targeted way, I think it still can have big impact.
Anyone else have anything on what states have done?
If I might mention, Texas has something called the Emerging Technology Fund. I think it's funded to the tune of about $100 million per year, and that money is passed out to aspiring small startup companies. Many of them are actually pre-venture capital companies, so they're very early stage funding. Some are later stage funding, and that actually has been very successful in terms of Texas being able to support a wide variety of different startup companies in different industries. I think that program has been pretty successful.
I'm also aware that in the past, the state of New Jersey has allowed small entrepreneurial companies in certain industries and meeting certain qualifications to sell their state net operating loss carry forwards to large industries. The large industry buys it and uses it as a credit against their own taxes, if you will. The state of Wisconsin has a program of matching SBIR and STTR grants for certain grants and in certain segments of the industry. The state of Indiana has a program that supplies grants for the development of science that is invented inside the state and commercialized inside the state. And the state of Illinois is considering a number of these different approaches to try to build a greater center, if you will, of nanoscience and a center of excellence in that area.
The state of Washington for many years has had an organization called the Washington Technology Center, which is a state-funded or initiated user facility that performs work for a large number of companies and also has twice annual competition for research support grants for companies. They're right adjacent to the University of Washington Nanotechnology Center. They've been a model for us in a lot of what we've done. In Oregon, we have the Signature Research Program. ONAMI is the first Signature Research Center. There are two more now, one in sustainable technologies, another one in infectious disease drug discovery. I think one of the things that's worked very well, maybe better than we thought it would, is encouraging the research universities in the state to collaborate very deeply with one another. That sounded like something that might be difficult at first, but in fact it's gone exceedingly well. And we have ideas, success in raising research funds and commercialization that would not have occurred but for that collaboration.
I, of course, have to acknowledge that the Center of Excellence at our university was funded by the state, and they're actually providing bricks and mortar money for a new building. But I think one thing that's a little bit of a difficulty in terms of state funding is that, again, because nanotechnology cuts across industry sectors, it can have relevance to biotech, it can have relevance to energy, to automotive, that it's not like a sector where you can have a whole bunch of companies that are in existence that come together and go to the state and say, we need this. We have that in the state in terms of biotechnology, but there's not really that equivalent cluster of nanotechnology identified companies in the state, even though many of the companies in the state do benefit from nanotechnology. I think that's one consideration.
Thank you. I look forward to the question. Maybe let me throw this out. I don't want to get an answer to go into the question that Chairman has. In terms of education, what we really need, are we looking a broadly educated, or I should say, are we looking for in a workforce to work in nanotechnology? What exactly are we trying to do, and does that mean just encouraging STEM education across the board, across all students, or are we looking for something more concentrated? But with that, I'll turn it over to Chairman Baird for his question, I think, on education.
Let's take that as a friendly amendment to my question and open that up to what we need to do and how we can better do that, and how the nanotechnology initiative might adapt it in some fashion to encourage that, or if there's another vehicle that might be better to do it.
I guess I'll start. One of the panelists mentioned internships or experiences for students. We call that inquiry-based science and think this is extremely important. You know, you can talk to a child and try to push information, but the experience of doing something is very powerful. The Nanoscale Informal Science Education Network is a great thing. We're very proud of our local Oregon Museum of Science and Industry for the outreach that they're doing even in rural parts of the state, also towards those experiences. The goal, of course, is to have, you know, U.S. citizen students, you know, persist, you know, through graduate degrees. There's an increased demand for graduate degrees. And in the absence of sufficient numbers for those in the time being, I have to agree very strongly with the other panelists that we must keep, you know, the immigrant advanced degree people that we've educated here. Otherwise, in the short term, they'll create jobs overseas.
Let me follow up on that issue for just a second. I believe that we ought to expand H1, but my own belief is that I can tell you in our local community there are industries who have really stepped up to the plate to try to educate the local populace. They take PhD level, put them into the schools. They bring high school and community college students into their labs to work in an internship setting. And quite frankly, there are other comparable high-tech industries that don't. And interestingly enough, it's the latter that tend to be busting down our doors to expand H-1Bs. And I would much more be inclined to link increased H-1Bs, and we'll hear, I think, tomorrow from Mr. Gates probably about the need to expand H-1Bs. I'd be much more inclined to expand H-1Bs based on a demonstrated effort to educate the domestic populace rather than just ignore the domestic populace in the sense of, and I guess I'm well aware there's this piddling $1,500 fee you get for an H-1B, and that goes to an education, and that's been used pretty well. But quite frankly, given some of the data about underfunding and underpayment of H-1B recipients here, how can we do this? How can we, you folks in the industry, reassure the American people that we're going to try to educate our own kids so they can fill these gaps rather than just trying to get folks from overseas, as valuable as they are, and maybe have a synergy there to where if you bring every H-1B you get, you have to demonstrate you're educating 10 Americans, something like that. I just put that out there. So I'm sympathetic to it, but I hear it far too often where high-tech people come to us and say, expand the H-1Bs, and when we knock on their door and say, what are you doing for mentoring? What are you doing for internships? What are you doing to invest in the local schools? What are you doing to fund their local labs? Oh, gosh, you know, we're just too busy. The economic climate's just too competitive, blah, blah, blah. And I'm kind of tired of it.
But I guess my recommendation would be to identify and speak with the large industry associations that are asking for the H-1B visas and just lay it on the table. They understand a simple partnership as well as anybody. I tend to agree with you. My biggest goal is in fact to make sure that we provide, you know, a green card, for want of a better expression, to every student that graduates from a large research university with a postgraduate degree in an area this country needs. Now, I know that's difficult to put in place in the present environment, but it's such a simple thing to do that I think everyone would agree that it would be a good thing to do, but it's difficult for us to make it happen.
I would fully support it, providing that the green card gets revoked if you don't dedicate some of your time after you got the green card to educating American citizens.
That's fair enough. You can cut the deal whatever you want.
I guess just briefly back to the question on the education. I think the first thing that obviously we would love to see is if the NNI can in fact fund all of the stuff that's in the American Competes initiative and act. Obviously we weren't successful necessarily in getting that through every year. I think there's a lot of really good programs there, both for helping research as well as education. But the other thing I think that the NNI could do in its reauthorization is try to identify some grand challenges and big initiatives that can capture the public mind. I think the nanotechnology is so large and so vague that sometimes it loses some of its credibility, or at least maybe its graspability by the general public. Maybe you know, looking for the next transistor isn't quite as sexy as putting a man on the moon, but we can find some things out there in nanotech that we could list up there as something to grab people's minds and hopefully encourage students that this is an interesting area to go into. And lastly, to your question on what kinds of education we need, I do think it's much more cross-functional than it used to be. One of the things we've found is we are working a lot more with physicists and chemists, and wishing we had more people who knew organic chemistry in the semiconductor side as we're trying to transition into more nanotech or nanoelectronics sorts of applications. Most of us were trained more on the inorganic side of things and more on the engineering side. So we need people with those skills, but we need them from the very beginning to be talking with engineers and getting an engineering background in their education so they understand how you take organic chemistry and actually make a device or make a product out of it.
As you may know, the America Competes Act specifically addresses cross-disciplinary research and funding for that kind of training. Unfortunately, we get to the appropriation last year, but we're in the budget, which just passed the committee last week. We have made space for substantial increases. Bring that budget up tomorrow on the floor, and I expect the Democratic budget will pass, and it has large allowances for substantial increases in funding for America Competes related activities. Other comments on the education issue, especially how we can scale it up to people who are not necessarily located in the centers where you've got your equipment directly available.
We've been involved in a project with the FEI company with a tabletop scanning electron microscope that was actually demonstrated here in Congress last year. I believe there is a Nanotechnology in Schools Act that Congress is considering that would provide funding or an opportunity to place low-cost tools that expose students to hands-on nanoscience, and so that would be one example, looking for placement of those in community colleges or traveling units. OMSI is going to be doing some effort in that area, for example.
If I were a kid in rural southwest Washington, is there a way I could go on the net and tinker with it remotely with some nanotech equipment? Dr. Chen, you seem to have.
Yeah, there are programs where they've set up through the internet. You can sort of access a atomic force microscope and get a feel for what kind of images you could get out of it. And so I think those are things that we need to do to get the excitement in there. I mean, a middle school kid may not end up working in nanotechnology, but if they get excited in science and STEM areas, that's a win for this country. I mean, I think you make a very strong point in terms of forward thinking that we can't just rely on people from overseas over the long term, because as things get better, they're not going to come. Why would they leave their country if things are as good there? We need to get kids in this country excited about science and engineering, because if they don't get excited at that middle school level, there's not a lot we can do to recapture them at the undergrad or graduate level.
I'm a former middle school science teacher, so I can appreciate a lot of these comments. I think there's a tremendous opportunity in dealing with the community colleges in this country. There's a great network of resource there. There's an opportunity there not to train necessarily PhDs, but the supervisory, managerial, technical talent that we require in order to commercialize. Not necessarily perform basic science research, but to commercialize. And I think a government-industry coalition to pull together a curriculum that could be broadly disseminated across these community colleges would go a long way. It would go a long way towards solving problems within the next few years, as opposed to a generation away. However, we still need to underwrite the generation away, and that simply is just more math and science teachers. I personally participate in education of math and science teachers with respect to nanotechnology and have done a lot of local work, but the local work alone is not sufficient.
I appreciate that. We had I'll recognize Dr. Ehlers in a second, we had a comprehensive review in my district, and one of the interesting things was I invited fellows in charge of production management for SEH America, Silicon Wafer, and he listed a number of the things that he needs employees to be able to do, and it was such things as look at an array of numbers and try to get a sense of what the mean, the standard deviation is, and what numbers are beyond the bounds, and then trace that through some other charts and figure out what here may have caused the deviation here. He said they can't find people to do that, and we're talking high-level jobs, we're talking potential billion-dollar investment in our community, and just a fairly rudimentary mathematical reasoning sequence is difficult. But what was also intriguing was the local educators said that they had been trying for a long time to get the high-tech community to articulate clear-cut, defined, achievable goals, and until he had done that at that presentation, they had lacked that. So there's a huge disconnect between the educational community and the consumers of the so-called supposedly educated workforce, and we need to close that gap, and your notion of a curriculum might go well along the way towards that. Dr. Ehlers.
Thank you, Mr. Chairman. The one surprise so far is that no one has mentioned health and safety issues, and so I feel obligated to raise those issues. Dr. Chen, you mentioned that you have environmental health and safety researchers working side by side with the nanomanufacturing researchers in your Center of Excellence. I would like you to amplify that, but Dr. Melliar-Smith and Mr. Moffitt, I'm wondering what type of health and safety precautions do you have to take in your facilities to minimize employee exposure to nanoparticles? So Dr. Chen first, and we'll just work down the line.
Yeah, one of the things that we discovered actually in talking to the EHS researchers, they were so happy to be involved at the stage where we were looking at creating new processes, because what they said was usually what happens is people call us in after the fact and ask us to try to clean up the mess. And so the exciting thing there is that they really are side by side. I mean, there's someone making product and there's someone measuring exposure. And so they can, by being right in the lab, they can make suggestions, they can take measurements, they can understand how the manufacturing process might go so that they can also make suggestions as to how that process could be designed to be more environmentally friendly. And so I think that's a key. The EHS research, a good chunk of it can't be done in isolation because there's too much to look at. It needs to be focused in terms of what are the issues if we go down a certain pathway for a manufacturing process? What are the issues for a particular type of application? And I think in the near term, that's going to get us there a little faster. I mean, we won't be able to solve all the problems, but we may be able to address some of the more urgent problems sooner if we get those groups together.
Would you consider your center to be a green center?
I would. I mean, it's a very important piece, and it's a unique part of Lowell that we have this very strong health and environment group as well as the manufacturing.
Okay. Mr. Moffitt?
We make a biologically reactive gold nanoparticle. So we must concern ourselves both with the biological components of what we do as well as the nanoparticle structure. We start with the premise that gold is an inert, noble metal, and as such is not an active particle, if you will. But once we functionalize it, it becomes active. So we do some, I would not call it core research, but we do some basic safeguard measures that you would expect in any biological facility. So we manufacture products in a clean room environment, in an isolated environment. We have P2 labs, which are labs that are capable of handling infectious agents and disposing of them properly, and monitor, of course, on a safety basis every step we take in the handling of these materials.
Dr. Melliar-Smith?
Well, I think health and safety goes without saying. It would be incredibly irresponsible for any CEO or any citizen, for that matter, of the country to do something which would risk the health of their employees or anybody of their neighbors or what have you. In our particular case, the nanoparticles that we produce are actually patterned onto a substrate, so they stick to the substrate. They never come free. They never float in the environment the way that if you were manufacturing carbon nanotubes or something of that sort. So in fact, the product we make does not represent any form of nano or biohazard to the community, but I strongly agree that the nano industry has to step up to the environmental risks that potentially very small particles do or could create in the environment, and I think it goes without saying we have to do that.
Thank you very much. I have no further questions.
Dr. Lipinski.
Just very quickly, what can we do in the NNI, if anything, to first of all do all that we can to make sure the proper work is done so that we do not have these environmental concerns, health concerns, anything with any kind of nanotechnology? And what can we do to convince the public about that? Is there something that should be done in the NNI? I think you individually talked about what you do, where you are at, but is there something more general that the government could help in this area?
If I may. I've written extensively about this in my written testimony. Green nanotechnology is ONAMI's single largest program, and in fact, in about 10 minutes, day 2 of our Greener Nano Conference will be getting underway in Corvallis, Oregon. I left day 1 to come here. The summary is that you want to link the research on implications with the research on applications, and you need to have a comprehensive program that is multidisciplinary, unites multiple agencies and objectives together. The best example that I'm aware of this, and we're heavily involved in it at the leadership level, is the NIEHS-led Nano Health Initiative, which is breaking out into 3 projects. One on characterization of nanoparticles, which is critical. Without data, nothing else is going to be achieved. Biological assays that are efficient and practical to perform, and then very importantly, and the part that we're currently leading, is a system of federated databases so that data can be shared and be consistent on the interactions of engineered nanomaterials with biological systems. This three-part project would be a great way to fill the gap between, what current EHS funding in the NNI is and the 10% or so that the NanoBusiness Alliance and other groups have suggested would be appropriate. It brings together multiple federal agencies, industry, academic centers, and I think it's an extremely promising initiative and following exactly the right approach.
I've already made some prior comments, so let me just add one additional thing. I think we want to also recognize that EHS research also will benefit from the creation of tools that will make it easier to measure and understand what's going on. So I think we want to make sure that there's a recognition for that piece of the EHS research aspect.
I think that one of the things that we fund through the SRC is an EHS this research group down in Arizona, again a multi-university center, and that was initially started both with SRC, Semitech, and NSF funding, and I think that the NSF funding was specifically very important in getting that going. And that's actually branched out from not just doing EH&S on the semiconductor manufacturing processes, but also looking for environmentally benign semiconductor manufacturing processes, ways to use less toxic chemicals, ways to manage that chemical stream as best we can. So I think that kind of incentive where the government's willing to put in money along with the industries to try and go after some of these problems in basic university research is a big help.
One other quick question. What do you think would be better? Well, first a plug for my alma mater, Northwestern University. I got my mechanical engineering degree there, but Northwestern has really put a lot into nanotech and has been very successful, and the commercialization has been very successful. Is it best to have some centers of excellence rather than to spread if there's federal funding, spread it around? Is it better to do it that way? I think someone had maybe suggested that earlier. I just wanted to put that out there.
So I think it is a balance. I mean, unfortunately, a lot of the tools that you're going to be needing for this kind of work are extremely expensive, so you can't afford to put one at every university. But I think the idea of doing multi-university centers that span across large geographies has worked well. It's worked well with the NNIN that the NSF put in initially for nanofabrication work. It's the same kind of thing we're trying to do with NRI. I mentioned we had 3 already, and we're hoping to get a 4th open soon. I think it balances then trying to limit your investments to what can be afforded, but also tries to pull in as many universities as you can. And I would note that even though we center these in distinct states, they actually do pull in schools from other states. So actually, to your question earlier, for example, the California Center in the new proposal that we just are about to announce is pulling in the University of Iowa, because there were a couple of professors there who were doing some very interesting work. So they said, okay, we'll become part of our center. Geographically, we'll have to work it out with telecons, but it's a way then to get that school also very much involved in that work. So I think that you can work around centers and then expand them out, particularly if you give them a mission that they're going after, so everyone understands why they're working together on this problem.
I guess I'd like to second that. In my experience in the industry, I think the SRC and the Marco centers have done a very good job of balancing individual contributors who can come from anywhere, because any good idea can come from anywhere, with the larger organizations which have got the center of gravity they need to actually be successful in commercialization. So I think if you're looking for a model, indeed, I think the Semiconductor Research Corporation is a very good one.
I would just echo the comment that I think the Center of Excellence approach is the right approach, simply because it does focus and channel available resources, and they are constrained, as we all know. And then I think they do logically and organically grow from that center as developments are made. Companies get spun out for commercial viability and commercial translation of the science, but that just loops right back into the university and other universities in the area, as well as other companies. So you tend to think of it as just dropping a few seeds here and there, and from that will grow, I think, a tremendous industry.
One thing I would say in caution, though, with the Center of Excellence approach is that we want to make sure, and I think I said this in my statements before, that we don't define nanomanufacturing as only one type of process. because as we've seen with the predecessor to the NNIN, that was very heavily based in lithography-based processes, because that's the industry that was more actively in the nano area. In the new version of it, they've added, for instance, the University of Washington that added in some more biological capabilities in terms of nanomanufacturing. So we don't want to too narrowly define what we mean by nanomanufacturing when we define what types of centers of excellence we should have. So I think that's important.
I think every center of excellence is going to be a center of excellence in nanoscale science, because that is the cutting edge of chemistry, condensed matter physics, and molecular biology. Nanotechnology affects every conceivable economic sector, and so we should think of this not as something esoteric or, as many people have said, tied to a single industry, but it's very, very broad. So there are going to be many, many centers of excellence, each of them focusing on something they do uniquely well. And so that, I think, might be the appropriate vision to have.
Thank you.
We'll finish shortly, but I wanted to just raise one other or two other issues. The issue of access to federal facilities, particularly Dr. Melliar-Smith, you mentioned the DOE labs. How well is that working? Can we make it better? What are the obstacles that any of you have experienced in terms of access to these federal facilities that provide the infrastructure, if you will, that allows people to do some of this work? How can we improve it, and what are any strengths or weaknesses?
My experience has actually, it's been very successful for us. Obviously, inevitably, there is a balance between what a company wants to do in a research facility and what the facility itself can let them do. There are certain constraints, obviously, ultimately, but our experience at Berkeley has been excellent. They've allowed our research engineer to come in and use the equipment largely unsupervised after full training. We've had a lot of other experiences too, which I think have been successful. We've been able to utilize facilities at Semitech, which, as you know, in its original genesis was heavily supported by the U.S. government. That made access to us in terms of clean room and processing facilities. We're extending that now up to the Albany Nanotech Center. So these are things that we just couldn't possibly afford to put in the infrastructure ourselves, and they're critically important to us. Generally, we have not had a problem with them. At any given point in time, there may be an aggravation over this, that, or the other, but they're all solvable on both sides. So we've been very supportive.
So actually, since we just formed this new partnership with NIST, we're very interested in how we can leverage the labs. And one of the things that the partnership started off with was the idea that NIST was very interested in having people come and utilize the labs, and we were very interested in taking advantage of what was there. But without an actual set of projects to go after, oftentimes it was difficult to figure out how you start the collaborations off. So one of their goals with funding some of the research at the universities as part of the NRI was to get better insight into what the researchers were doing, to understand what they actually needed for future characterization tools. Measuring the spin of an electron is something that's extremely important to us right now, and that's the kind of grand challenge that NIST can go after extremely well, and probably no individual university can really solve that problem with its own resources. So I think leveraging the labs on specific projects, particularly for things that require tools or capability that's really beyond what a university can have, is very important. What I think is less effective is if we rely on them to have all the fabrication and facilities that were needed to do the daily research of the students. I mean, it's fine for a student to go to a lab for a week, a month, or whatever to go work on a specific aspect of his project, but he really needs to be also back at his university working with his research group and his professor as he goes through. So that's why there needs to be a balance between investments in very large, one-of-a-kind sorts of tools and capabilities of the labs with more pervasive investment at university centers to allow the students to be able to do work both places.
Number of people nodding their heads to that, apparently consensus on that. One last question, Mr. Moffitt, you talked about the $100 million venture cap or financial investment in bringing it from concept to manufacturing. Obviously, if we took the entire NNI and if we were to try to say, well, we pretty quickly use up our funds. I was speaking with a gentleman named Yossi Vardi, who's a venture cap high-tech entrepreneur in Israel, and he had a very intriguing idea about and I don't fully, I won't articulate as well as he knows it, but an example wherein the federal government somehow indemnifies the venture cap folks, that we share the risk, but also share in the profit, so that you are able to leverage upfront money. Any thoughts about a mechanism like that versus, say, just a grant that goes and then we don't necessarily get anything back from it, but some kind of a collaborative indemnification slash repay model wherein then we recycle the funds? Any thoughts about that?
I hadn't thought about the repay part of it yet.
That would not surprise me. We seldom get the repay question. Oh, you mean we have to pay this back? But
right.
That allows us to leverage the money, and you would get it up front. You get the real startup kick, and then we can give it to somebody else.
Of course, the repay comes in the form of us being successful and ultimately paying taxes, in part. But I would say
so. You're calling for special higher taxes for?
No, I do think, though. I do think there's a. I would make the point again that what the programs that exist today, SBIR, STTR, and these kinds of things do, they do serve as validators. And, as I said, there's a tremendous amount of private equity out there willing to be invested. The question is where and how do they separate the winners from the losers? They certainly will pick the right industry and industry segments. And I do think that there is a way to develop a program of investment credits so the government does share in the upfront risk. But I agree, it's appropriate to share in the downstream reward and perhaps something, over and above just paying routine corporate taxes.
Certainly in the Texas Emerging Technology Fund I spoke about, one of the criteria for that investment is that the company receiving the investment provides the state with warrants for common stock such that when the company is successful and goes through an IPO, the state essentially gets paid back with a lot of profit to boot, assuming the IPO is successful. So I think there are many ways, and again, I would encourage Congress to be innovative about asking for what you think you want from industry. It seems to me it's not at all unreasonable that if the government or a state establishment makes a significant investment in a company, that there's a way to get the money back. And the venture capital industry has lots of different ways for you to get your money back. That's what they specialize at. It's what they do all the time. And so it's just a matter of sitting down and saying, okay, I want to try to form a partnership with industry, and here's what I want, and here's what you want. And it isn't just a one-way street with checks being cut in Washington, but it is in fact a partnership, whether it's a partnership in education, whether it's a partnership in returning the rewards. All of those things can be very easily put on the table.
Other thoughts or additional thoughts, Ms. Moffitt?
And additional thoughts, so I strongly agree with that, and I think the Texas model as it was described to be is excellent. I contended fairly strongly for gap funds, and I'll simply add that I don't think that is going to take a great deal of money or would be a large percentage of any given grant or the NNI. The needs of our gap grants are about $250,000 maximum, and that can do a great deal, to get a company from, the proof of concept stage to the point where a venture capitalist, can consider it as an investment. So I simply would leave the thought that these don't have to be large amounts.
I should make a shameless plug for a bill we've got actually recognizing this gap, which is, ironically, many of our federal funds are available for startups, and then at the end, and in this middle, there's this valley of death you mentioned. We have a bill called the Bridge Act, which we introduced a couple years ago, which would allow rapidly growing companies to reinvest their tax liability in building the company, and then later on, once you've built up, you would pay the tax back with modest interest. So you're basically loaning yourself the money rather than, it's one of these catch-22s. If you had the money, you could expand, and if you could expand, you could pay more taxes, but because you don't have the money, you can't expand. And especially in your kind of industry, we need to find creative ways to not penalize, but in fact reward and incentivize the risk-taking, the expansion. In this Bridge Act, which I introduced on the House side, and Senator Kerry's our co-sponsor, or the Senate rather sponsor. We're trying to make a run at it because, interestingly enough, there's some upfront cost to the Treasury, but in the long run, our best estimates and CBO's estimates would generate hundreds of thousands of jobs with a net profit to the federal government, because we would actually generate revenue. Here's a tax reform, not a tax cut at all, just a change in how and when we collect the tax and what's done with the money in the interim. And if anybody wants information on that, we'd be happy to share you with that. Dr. Ehlers, any closing comments or questions?
Not really. I was just going to say that's the same rationale for the Bush tax cuts, but
no, it's actually much different.
But I won't say that.
It's actually completely different. It's not a cut. You're paying it back. The point is you're still paying the same rates on it. You're paying it back over time, but only on the proviso that you reinvest the money. But you actually have to pay it back. It's a much different structure.
Thank you. I didn't intend to start that discussion, but I couldn't resist that.
We would all. I let you pass on the John McCain seems to be the only person who's dealing with immigration in a responsible way, but I just couldn't get the Bush tax cuts go by. If President Bush would actually support the Bridge Act, I would support the president in that support.
Yeah.
I want to thank our witnesses. We've digressed to much less pleasant topics, but this has actually been very, very fascinating, highly informative. I hope we will use your information well enough to justify the red eye and the time away from your most important research. We look forward to great things, and we may well follow up. Also, if there are suggestions that you feel you want to add, sometimes these interactions stimulate further thought. You may go back and say, here's a creative way. We are the reason we do these hearings is so that the legislation that comes out in a few months will actually be the best we can possibly make it on this round, and it's an iterative process, as you know. So if there are further thoughts, we would welcome those, and thank you. With the gratitude of the committee, this hearing stands adjourned. We're grateful for your presence. Thank you.